We were discussing our instruction set. What category of instructions did we discuss last?
Logical and machine control.
Logical and machine control. And then we had started with the discussion of string instructions, right? Okay. So, but then I don't think anybody of you might have paid attention. Okay. I had just discussed what is the motivation for having this category of instructions, which is called as string instructions. Does anybody remember the reason why we go for this category of instructions?
They are faster compared to the normal data transfer instruction.
Yes. So I had given you the example of move instructions, right? So if I'm writing move CL, 2000H, how many bytes am I transferring? If I write move CL, 2000H, how many bytes or how many bits of data am I transferring? CL is an how many bit register?
8.
8-bit register. So here you are actually transferring 1 byte of data, right? Even if you write move CX, 2000H, you're transferring 2 bytes or 16 bits, right? What do you mean by move CX, 2000H? You are transferring data from both location 2000 and location 2001, right? Sorry, you have to put this in square brackets. Now, so if I want to transfer 1000 bytes of data from one location to another, if I'm using only move instruction, I'll have to write the statement 500 times, right? I'll have to write the statement 500 times if I want to transfer 1000 bytes. Now that is not required in case you are using a string instruction. So that was one of the motivation for going for another category of instructions, which is called a string instruction. So if I'm using a string instruction like move S is a string instruction which is used for transferring a block of data from one location to another. If I'm using move instruction, I'll have to write the instruction 500 times. That means I'll be fetching the instruction 500 times. I'll be decoding it 500 times and then I'll be executing it. But if it is move S instruction, if I'm using, I'll be fetching and decoding it only once and I'll be executing it 1000 times. So string instructions are comparatively faster than the normal data transfer instructions like move. This was one point which I discussed in the previous session. And then I'd also mentioned about certain rules which you have to follow when you are using string instructions. Do you remember that? There are 4 rules which have to be compulsorily followed when using string instructions. Does anybody remember the rules?
I'm about source string and destination string ना थोड़ा.
हाँ, the source.
Source का सब कुछ ऐसा data segment में होना चाहिए.
Yes.
दूसरे का extra में.
The first rule was that the source string should compulsorily be in which segment? Should be in the data segment. That means suppose I want to move one string from one location to another. Your source string should be there in the data segment and the location where you're moving that string should be there in the extra segment. So the rule number 1 is that source string must be compulsorily present in the data segment. Rule number 2 is what? The destination string should be compulsorily be present in the extra segment. What was the third and fourth rules? Does anybody remember? What was the third and fourth rules? Who gives you the offset address of the data segment?
Source index register.
Source index register. That means if you are accessing a string which is there in the data segment, that will be given by which register? That will be given by the source index register. Similarly, if you are accessing a string which is there in the extra segment, who will give you the offset address? That will be given by the destination index register, right? DI register. So rule number 1 is that source string must be compulsorily present in data segment. Rule number 2 is that destination string must be compulsorily present in the extra segment. Third rule is that the offset address of the source string must be given by the source index register. And the fourth rule is that the offset address of the destination string must be given by the DI register, right? So we had discussed one example also, right? I told you if I want to move some data from this address, this physical address to another physical address 67892. Where is this address going to be? This is going to be in the data segment. Where is this address going to be? This is going to be in the extra segment. So my source should be in data segment. My destination should be in the extra segment, right? Who will give this address? How do you split up this address? What is the formula for physical address calculation? What is the formula? Physical address is equal to segment address into 10 plus offset address, right? This was our formula. So how do you write 1, 2, 3, 4, 5? 1, 2, 3, 4, 5 will be written as 1000 and 2, 3, 4, 5. Where will this address go? Where will this address go? In the DS register.
Data segment.
And where will this address go? In the SI register. Similarly, 67892. So this will be 6000. This will be 7892. This will be where? In the extra segment register. Where will this be? This will be in the DI register, right? So this was another point which we had discussed in the last session. Now we'll proceed. Okay, we'll proceed to the string instructions one by one. We'll be discussing all the string instructions one by one. We'll start with the first instruction, which is move S. Okay, students, we are going to use all these instructions when you are going to write programs. Okay, see, we have discussed arithmetic instructions, we have discussed logical instructions, we have discussed shift rotate instructions, then we discussed branching and looping instructions. Now this is the last category of instructions, string instructions. So you might have observed that we are using these instructions when we are writing assembly language programs. Okay, suppose if you get a problem statement where you have to do something on strings, say for example, if I give you a program, write an assembly program to check whether a string is a palindrome or not. How will you do that? You will have to make use of string instructions, because there the problem statement has to work on strings. So for that you should have the knowledge of what are the string instructions. So today we'll be discussing what are the various string instructions. So the first string instruction is move S. Move S means move string. Okay. So it's a string instruction which is used for moving a string from one location to another. So when I say one location to another, immediately understand that your source location will be in the data segment. Your destination where you're moving the string is going to be there in the extra segment. Okay. So that means you're moving something from the data segment to the extra segment. Okay. So your source will be in the data segment, your destination will be in the extra segment. Okay, and the offset addresses will be given by SI and DI, right? Now what you have to remember is that every string instruction, okay, every string instruction has two versions. Okay, one is the byte version and the other is the word version. Okay, any string instruction, most of the string instructions have two versions, the byte version and the word version. So that means move S has now move SB, and move S is also work as move SW. So move SB means it is the byte version. So it means move string byte. Move SW means it is move string word. So this is the byte version and this is the word version. Now we need to see how the byte version works and how the word version works. Okay. Are you getting it?
Yes, ma'am.
Yes, ma'am.
Okay. So what does move SB do? Move SB will transfer only one byte at a time. Okay. That is why it is called as a byte version. And move SW will move how many bytes? It will move 2 bytes or You can say one word at a time. Now we don't have a move SDW, double word. Double word means what? How many bytes? Double word means 4 bytes. We don't have a move SDW. Why? Whose instructions are these? Whose string instructions are these? It is 8086 string instruction. And what is the capacity of 8086 data bus? What is the capacity of 8086 data bus? What is the capacity of 8086 data bus? Khatam. Bolo, what is the capacity of 8086 data bus?
16 bits.
16 bits. So that means we can transfer how many bytes maximum in one clock cycle? 2 bytes, right? 16 bit means 2 bytes. That is why we don't have a double word. That doesn't mean that we can transfer only 2 bytes. I told you we can transfer 500 bytes, we can transfer 1000 bytes, we can transfer larger bytes. Okay, how do we do that? That is done by using a prefix which is called as REP. Okay, so if I write REP move SB, what does it mean? I'm moving bytes only, but I'm using a prefix REP. That means this is going to repeat for some number of times. Okay, so by using the REP prefix, you will be able to transfer larger blocks of data. So what you have to understand right now is move SB is the byte version, which is used for transferring only 1 byte at a time. And move SW is the word version where you can transfer 2 bytes at a time. But if you want to transfer larger blocks of data, you will have to use the prefix REP with move SP or move SW. Okay, that's up to you. But by using the REP prefix, you will be able to move larger blocks of data. So what does this mean? This actually means that you're moving some data from which segment? You're moving some data from data segment. Sorry, from data segment, which is indexed by SI to extra segment, right? How much data are you moving? If it is a byte, it means you're moving only 1 byte at a time. That means your SI will get incremented or decremented. Your DI will also get incremented or decremented. Okay, and how many times this will happen? It is REP. REP means repeat. Okay, REP is short form for repeat. How many times it will get repeated? As many times as the value which is there in CX register. Okay, so this repeat prefix works based on the value of CX register. Now you tell me, why did I write plus or minus 1? Why did I write it as plus or minus 1? See, if you're moving, suppose I want to move a block of data which is there in data segment to extra segment. So first, suppose this is apple. Okay, first this is apples. I want to move apples, which is currently in data segment, to some location in the extra segment. So I'll be doing it bit by bit, right? Byte by byte. So first I'll be moving A, then I have to. So initially SI will be pointing here. So first I'll move A, then I'll increment SI, right? So who is pointing here? Who is the index register here in your extra segment? DI. So first what I'll do? First I'll move A here, then I'll increment SI. I have to increment DI also because DI should point to the next free location. Then I'll bring P here, right? Then I'll again increment SI. Then I'll also increment DI. And I'll bring this P here. This is how you transfer bytes, right? Yes or no? Are you getting it? Are you all paying attention?
Yes, ma'am.
हाँ, but यहाँ पे मैंने plus नहीं लिखा है. Right now I am doing plus only. But why did I write it as SI plus or minus 1 and DI plus or minus 1? Why? There should be some logic, right? Why I wrote it like that? What is special about string instructions? Okay, I'll give you a small hint if you're not getting it. My hint is this. That's my hint. What is DF? What is DF? It's an element in your flag register. What is DF?
Direction.
Direction flag. So what is the relationship of direction flag over here? That's my hint. Direction flag is my hint. Abhi bolo answer. Why did I write it as SI plus or minus 1 and DI plus or minus 1? Because strings can be processed in two directions depending on the value of direction flag. If direction flag is a 0, it is what? It is auto increment. If direction flag is set as a 1, it will work in which direction? It will work in auto decrement direction. See, apple, if I want to copy, I can proceed in this direction and copy. I can proceed in this direction in the auto decrement address manner and copy. The operation that I'm doing is copying only. So I can do it in auto increment address manner or auto decrement address manner by setting and resetting the direction flag. So if I do CLD, clear, if I use the instruction CLD, it is clear direction flag. So if I clear direction flag becomes 0. That means I'll be copying apple as APPLE in this direction only. Now if I use STD instruction, what will happen? Direction flag will become a 1. Now in which direction am I copying apple? First I'll be copying E, then I'll copy L, then I'll copy P, and then A. I'm going in the other direction. That is auto decrement fashion. So whenever we are working with string instructions, strings can be processed in auto increment manner or auto decrement fashion. That is why I've written SI plus or minus 1 and DI plus or minus 1. Did you understand this right now?
Yes, ma'am.
Yes. So when I use something like REP move SP, what am I actually doing? I'm transferring bytes from my data segment to extra segment, byte by byte. Okay. So that means when I'm doing that transfer, SI will get incremented in the process, DI will also get incremented in the process. But whether I'm incrementing or decrementing SI DI depends upon the direction flag, depends upon in what manner I am processing that string. Is it an auto increment manner or auto decrement manner? And how many bytes will be moved? The number of bytes that will be transferred depends upon the value of CX register. Got it, everybody? Got it, everybody?
Yes, ma'am.
So you now tell me, if I write move CX, 00A H, okay? And then I'm writing something like REP move SB. How many bytes am I transferring here? How many bytes will these two instructions transfer? How many bytes are getting transferred when you execute, when you use these two instructions? Come on. गलत हुआ तो क्या problem है? Just give out answers now. What comes into your mind? How many times?
2 bytes at a time.
Not 2 bytes at a time. Move SB means it is going to be 1 byte at a time. But I have used the repeat prefix. So it's definitely not 1 byte. It is multiple bytes. Now I'm asking you how many bytes are getting transferred here. Whenever I use REP, the number of bytes that are transferred is depending upon the value of the CX register I told you. What is the value in CX register right now? What is 000A? 10. 10. So how many bytes are getting transferred? 10 bytes. Okay. So even though string instructions has two versions, move S and move SW. This means 1 byte at a time is being transferred. This means one word at a time is being transferred. But you can transfer multiple bytes. How? By using which prefix? By using REP prefix and along with using the CX register. So depending on what value you are loading into the CX register, you can transfer that much data. That means what is the maximum size of data that can be transferred using these string instructions? What is the size of CX register? What is the CX size of CX register? How many bit register is CX?
4.
4.
Sorry, 16. Yes, sorry. 16 bit, 4 byte.
CX is a 16-bit register. That means what is the maximum count value that CX can accommodate? It is 2 power 16. How much is 2 power 16? 64 KB. That means using string instructions, you can transfer up to 64 KB data. Okay, string instructions can transfer maximum up to 64 KB of data. That means instead of using the normal move instructions, we can use string instructions to transfer blocks of data from one location to another. And using string instructions, we can transfer maximum up to 64 KB data. Okay, but there is a difference between your normal move instruction and your string instructions. What is that? Move instruction, if I write move CX, 2000H, this is doing only one job. This is simply transferring the data which is there in 2000H to CX register. But if I'm using a string instruction, it is not only transferring. String instructions are doing two things. It is transferring data, that is obviously there. Another additional job that your string instruction is doing is that it is changing the addresses. Means what? It is by default, it is incrementing SI and DI. So string instructions are actually doing two things. Along with transferring the data, it is manipulating. It is changing SI, DI. See, when you're transferring apple, it's happening byte by byte. So once A is getting transferred, SI is getting incremented, right? So that the next byte can be transferred. So string instructions are automatically managing this address change, that is incrementing or decrementing of addresses depending upon the direction flag. Okay. But in normal instructions like move, only data transfer is happening. Okay. So keep this point in your mind that normal data transfer instructions only transfer data. They transfer data. But string instructions, along with transferring data, they are also updating the SIDI registers. Got it? Are you getting it or not? Respond. I'm not talking to the wall. Girls?
थोड़ा मैम.
What do you mean by थोड़ा? मतलब थोड़ा, your focus is थोड़ा, इसीलिए थोड़ा समझ में आ रहा है.
नहीं मैम, लास्ट लेक्चर स्किप हुआ ना मेरा.
हाँ तो लेक्चर रिकॉर्डिंग अपलोडेड है ना. Why didn't you revisit it?
देखा नहीं मैंने मैम अभी तक. आज या कल में देखूंगा.
हाँ, that is your responsibility. Okay. तो मैंने बोला what is move SB doing? Move SB is transferring data, right? Along with it, it is also what? Incrementing or decrementing the source index and destination index registers, right? So move SB is doing what? It is transferring some data from your data segment to the extra segment. Simultaneously, it is also updating SI and DI. Now, if I want to write the syntax for move SW, how will I write? What will be the difference if I want to write the same syntax for move SW? How many bytes are getting transferred? It is not 1 byte. Here only 1 byte is getting transferred because this is the byte version. Here a word is getting transferred. That means how I'll write? 2 bytes are getting transferred, right? So it is going to be Am I right? What is the meaning? Joby, whatever is there in the location pointed by SI, it is going to ES of DI. Whatever is there in the location SI plus 1, is going to di plus 1. Right or wrong? Is it right?
Yes, ma'am.
Why? Because this is the word version. This is the byte version. So only one byte is getting moved. Here, 2 bytes are getting moved. Okay.
Yes.
And then what will be SI? SI will be what? SI plus or minus? Plus or minus? What value will come here?
2.
2. Yes, very good. So this will be di plus or minus 2 because it is the word version and this is the byte version. So our very first string instruction that we have learned today is what? MOVES. And keep in mind, MOVES has 2 versions. The byte version and the string version. Now, coming to the next instruction, which is load-s. Okay, load-s means load string. अरे अभी move है तो फिर load की क्या जरूरत है? Move is already doing the job, right? Now why do we need another instruction load? क्या जरूरत है? क्या जरूरत होगी? See, move क्या कर रहा है? एक लोकेशन में जो डेटा है उसको सीधा दूसरे लोकेशन में लेके जा रहा है. बट समझो मुझे ये जो डेटा है उसको बीच में थोड़ा मॉडिफाई करना है, मुझे कुछ ऐड करना है या सबट्रैक्ट करना है, मुझे वो स्ट्रिंग को थोड़ा मैनिपुलेट करना है. So in the middle, I want to do some manipulation and then I want to store the result inside in my destination. So this is my source, this is my destination. मतलब this is my data segment, this is my extra segment. So बीच में मुझे थोड़ा modification करना है on source string. In that case, which instruction I'll be using? I'll be using the load-s instruction. Okay, I can use load-s and store-s. There are 2 instructions which are similar. LODS means load string. STOS means store string. Okay, अभी load कहाँ पे कर रहे हैं? This means load string into accumulator from source. And what does this mean? This means store string from accumulator into destination. हमेशा याद रखो, सोर्स मतलब अपना डेटा सेगमेंट है, डेस्टिनेशन मतलब अपना एक्स्ट्रा सेगमेंट है. So what does load as instruction do? It loads the string into the accumulator from the source. What does store as do? It stores the string from the accumulator into the destination. तो मतलब बात इतना ही है, ये अपना डेटा सेगमेंट है, यहाँ पे कोई तो सोर्स स्ट्रिंग है which is indexed by SI. इसको आपको डेस्टिनेशन में मूव करना है. डेस्टिनेशन आपका एक्स्ट्रा सेगमेंट है whose offset address is given by DI. So you want to move some data, okay, say this block of data from here to here. But क्या है, आपको बीच में उसको थोड़ा modify करना है. So instead of directly transferring it using MOVES instruction, what you can do is you can first load this block of data into our accumulator. So load as use करके you can move this data into the accumulator. Accumulator से आपको जो modification करना है वो आप कर सकते हो, और फिर store as instruction use करके you can store your result into your destination. So did you understand the difference between the purpose of MOVES and LODS and STOS? Load as and store as. समझ में आया? Yes. So यहाँ पे भी you have 2 versions. Okay, you have a word version and you have a byte version. So here the difference is that for the byte version your accumulator जो है वो आपका AL register होगा, and for the word version your accumulator is going to be whom? Is going to be AX register. Okay, so for load S and store S also you have a word version and a byte version. मतलब load S B भी है, load S W भी है, ऐसे ही store S B है, store S W है. तो इसका syntax कैसे लिखोगे आप? What does load S do? It loads some content into the accumulator. How much content? A byte. Byte मतलब आपका accumulator कौन होगा? Byte मतलब who is going to be your accumulator? AL. So what does load S do? It moves some content from data segment which is indexed by SI register into AL. So मतलब अपना SI कैसे update होगा? SI will become SI plus or minus 1, depending upon the direction of your direction flag. What does load SW do? It loads not a byte, it loads a word. That means who is going to be your accumulator? AX is going to be your accumulator. मतलब कौन सा content जाएगा? Content will go from 2 locations because you are loading a word. A word means 2 bytes. So means content will go from SI and SI plus 1 to AX register. So how will SI get updated? SI will become SI plus or minus 2. Did you understand this logic? Did you understand this logic?
Yes, ma'am.
तो आप लोग मुझे स्टोरेज का बताओ. स्टोरेज में क्या? How will I write this syntax? How will I write this pseudo code? राइट साइड में कौन आएगा? स्टोर कहाँ पे हो रहा है? स्टोर कहाँ पे हो रहा है? सॉरी, लेफ्ट साइड में कौन आएगा? स्टोर कहाँ पे हो रहा है? What is STOSB doing? It is storing some content from where?
Destination में मतलब.
हाँ, from the
Extra
accumulator. हाँ, from the accumulator to the destination. Destination कौन है अपना? Extra segment. So how will you write this? ES of DI. कहाँ से content आ रहा है? AL से content आ रहा है.
AL.
Because this is byte version. और यहाँ पे कौन increment होगा अपना? DI increment होगा. DI can be plus or minus 1. इसमें क्या फर्क है? इसमें क्या फर्क है? 2 लोकेशन पे स्टोर होगा, राइट? कौन से है वो 2 लोकेशन? ES of DI and ES of DI plus 1. कंटेंट कहाँ से आ रहा है? कंटेंट AX से आ रहा है क्योंकि दिस इज आवर वर्ड वर्जन. और DI कैसे अपडेट होगा? DI will be DI plus or minus 2. Did everybody understand this?
Yes, ma'am.
Yes. So loaders is just loading your data from the source to the accumulator, and storers is just storing your data from the accumulator to the extra segment to your destination. और दोनों का word version और byte version है. Every string instruction has a word and byte version. Okay. That's it. So that's the difference between movers and loaders storers. I will go to the next instruction, which is CMPS. Okay. CMPS means compare string. Okay. Compare string. So what does it do? It compares string. So again, it has 2 versions. Okay. Compare string byte bhi hai, compare string word bhi hai. So this will compare the string byte by byte, and this will compare the string word by word. Okay. Matlab, if I want to write the syntax of compare SB, how will I write? How will I write? Who is being compared? Who is being compared? Suppose मेरे इसमें apple है. Okay, मेरे data segment में apple है और मेरे एक्स्ट्रा सेगमेंट में एप्लीकेशन है. ओके, मुझे इन दोनों को कंपेयर करना है whether they are same. So I'll be doing what? If I'm using compare SB, I'll be doing comparison byte by byte. That means basically what I'm doing, I'm comparing DS of SI with whom? I'm comparing it with ES of SI, right? Sorry, ES of DI, right? That means after every byte is compared, SI will become SI plus or minus 1, DI will become DI plus or minus 1, right? First I'll be comparing A and A. Then I'll be incrementing SI and DI, and then I'll be comparing this P and P, right? So what is compare SB doing? It is comparing DS of SI with ES of DI. Understood?
Yes.
So what will compare SW do? It will compare a word. It is comparing a word. That means it will compare DS of SI and DS of SI plus 1 with whom? With ES of SI,
Yes.
sorry, ES of DI and ES of DI plus 1, right? And here what will happen? SI will become SI plus or minus 2 and DI will become DI plus or minus 2, because this is the word version and this is the byte version. So what is the purpose of compare instruction? It just compares the strings byte by byte or word by word depending upon what version it is. तो मतलब हमने अरिथमेटिक्स इंस्ट्रक्शन पढ़ते वक्त हमने कंपेयर इंस्ट्रक्शन देखा है. What is that doing? If I write compare AL, BL और समझो AL में 12 है और BL में 13 है, what is it actually doing? It is doing subtraction. Do you remember? I told you this. Compare instruction actually does subtraction. Suppose AL और BL में दोनों 12 है, so it will give you the result that which flag register will give you the result? Which flag is going to give you the result that these two numbers are equal if both are having 12? Which
Zero flag.
Zero flag, right? हाँ, yeah. तो यहाँ पे भी वही होगा. In string instruction also you're doing subtraction only, but subtraction किसका हो रहा है? Subtraction ASCII value का हो रहा है. See, समझो, अगर आपके सोर्स में एप्पल है और आपके डेस्टिनेशन में भी एप्पल है और आपको कंपेयर करना है कि सोर्स में जो है और डेस्टिनेशन में जो है वो सेम है क्या, तो एप्पल का सब्ट्रैक्शन मतलब a माइनस a नहीं कर रहे हो आप लोग. क्या कर रहे हो? a का ASCII वैल्यू क्या है? 41, right? So it's actually 41 minus 41 you are doing. And if they are giving you the same, that means if it is setting the zero flag, 41 minus 41 आपका zero हो जाएगा, मतलब आपका zero flag set होगा. मतलब first byte क्या है? First byte same है. That means whatever is there in your source and whatever is there in your destination are the same because the zero flag has been set. So that is how compare works here also. So compare instruction simply subtracts the two strings, but it will not store the result anywhere. The result just affects the flag register only. The zero flag will get updated if the strings are equal. So if the zero flag is a 1, it simply tells you that the strings are equal. And if the zero flag is 0, it means the strings are not equal. Understood how compare works?
Yes, ma'am.
Okay. So it's basically used to just compare whether the strings are same or not. So far, how many string instructions we have discussed? We have discussed move instruction, byte word version, load instruction, byte word version, store instruction, byte word version, and compare instruction, byte word version. Now the next string instruction is scanf. Okay, SCAS. SCAS means scan string. Okay, अभी क्या है ये scan string? Scan instruction जो है SCAS, okay, scan instruction compares a single value in the accumulator with every value present in the string. Okay, for example, मुझे find out करना है कि apple में L है क्या. Okay, मेरे string में ये particular letter है क्या? I want to find out. So what I'll have to do? I'll have to put this L in the accumulator. Okay, so यहाँ पे मेरा ये source है. Okay, ये मेरा destination है, मतलब मेरा extra segment है. Okay, so now if I want to do a comparison, what I'll have to do? A में क्या डालूंगी मैं? L डालूंगी. Okay, and then where will I keep my apple? My apple will be here, and then I'll be comparing this L. I'll be scanning this byte by byte. Every character in my destination will be scanned to check the presence of this particular character. So what does scanf do? It compares a single value in your accumulator with every value present in the string. So basically you are using it to find out whether a particular character is there in your string or not. Okay, so scanf also has two different versions. It also has a word version and a byte version. Okay, so scanf instruction just compares. If it is the byte version, it will do comparison of byte by byte, okay, which is present in accumulator with every byte in the destination. Got it? So that means agar scanf ka byte version hai, so what it is doing? It is actually comparing byte version hai. What is it is comparing? It is comparing whatever is there in AL with ES of DI. If it is a byte version, you are making a comparison of AL with ES of DI. That means DI will become DI plus or minus 1. If it is the word version, what are you doing? You are not comparing AL. You are comparing whatever is there in AX with whom? With two locations. Which are the two locations? ES of DI and ES of DI plus 1. That means DI will become DI plus or minus 2. So this is these are the two versions of scanner's instruction. So what is scanner's instruction used for? Suppose, for example, you want to find out whether E is present in index. What you will do? You will put E in the accumulator and then you will make a comparison of E with every position in your destination register. So for that, you will be using the scanner's instruction. So again, that has a byte version and a word version. Did everybody understand the purpose of scanner's instruction?
Yes, ma'am.
Okay. So these are all the different category of string instructions. Now you people tell me, now it's your time, okay? Your time to pay back. If I write an instruction like REP move SB, okay? And then I'm writing move CX, comma 05, okay? That means some count value I'm putting. And say this could be anything, okay? The direction flag could be cleared or it could be set. How will you write the syntax of this instruction? See, to explain the syntax of this instruction, this is how you're going to explain the syntax of the instruction. So how will you write the syntax of this instruction now? That means this one, okay? How does thing work? Suppose somebody asks you to explain move SB with REP. Suppose somebody gives you this question. Explain move SB with REP prefix. How will you explain? Tell me. What is happening here? What will I write here? What will come in my left hand side? What will come in my left hand side and what will come in right hand side?
ES of DI.
ES of DI. Right. Here, DS of SI. So that makes only one byte. And then I have to mention the status of the SI and DX registers. DI will become what?
Ma'am, you are
Okay, sorry. I think there is some network fluctuation. So I told you, move instruction not only transfers data, it also changes the address. So you have to mention about SI and DI. Now, it's not simply move instruction. You have a REP prefix here. So what you'll have to write as the next statement? How many times will this process get repeated? How many times will the process get repeated? Till CX becomes 0, right? Till CX becomes 0. That means how many bytes are getting transferred here?
5 bytes.
5 bytes are getting transferred here. So this is how you will explain the syntax. That means as long as CX is not equal to 0, this is what happens when we execute the instruction REP move SB. Got it, everybody? Understood?
Yes.
Okay. Now, few more points which you have to remember when you are using string instructions. There are 3 types of repeat prefix. Okay. What is REP? REP is called as a repeat prefix. There are 3 types of repeat prefix. One is REP, which is unconditional repeat. So this is unconditional repeat. वहाँ पे कुछ condition नहीं है. Okay. Unconditional repeat. I'll give you examples to make this concept clear. The second type of REP is repeat if equal or repeat if 0. Okay. So what is this? This is repeat on equal or repeat on 0. Okay. The third category of repeat prefix is repeat if not equal and repeat if not 0. Okay. So this is what? Repeat on not equal or repeat on not 0. There are 3 categories of repeat instruction which can be used in different scenarios. Okay. REP means repeat if equal, repeat on equal or repeat on 0. Both are the same. Repeat if not equal and repeat if on not 0 are also the same only. Okay. Now, these three types of repeat prefixes can be used in different scenarios. For example, okay, just a minute. Just a minute. ओके, सपोज मैंने CX में डाला है कुछ तो वैल्यू, ओके, काउंट मेरा सपोज है 10, ओके, आई मे यूज REP, I may use REPE, okay, REPE or REPZ, whatever I want, or I can use REPNE or REPNZ. Okay, my count value is 10. Now you tell me, if I'm using REP prefix, how many times will my move instruction run? Say if I'm writing move SB, REP move SB, how many times will this instruction run? How many times? If I write REP move SB, how many times will my instruction run? That is my question. It is byte by byte. So how many times this instruction will run? It will run depending upon the value of CX only. So CX में currently 10 है. So how many times this instruction will run?
10 times.
10 times. But इसके केस में क्या होगा? How many times this instruction will run if CX value is 10? Will it run 10 times? It will run 10 times provided the value of zero flag is 1 in every iteration. Okay. So you cannot say that this will run 10 times. You can say that this will run maximum 10 times provided zero flag is a 1 in every iteration. Repeat if equal. Repeat if equal है. Equal मतलब zero flag 1 होगा. So this will run 10 times provided zero flag is 1 in every iteration. That means ये कौन से सिनेरियो में यूज होगा? कौन से सिनेरियो में यूज होगा? जैसे मैंने आपको बताया, मुझे एप्पल एंड एप्लीकेशन को कंपेयर करना है. If I want to find out whether they are same, do I need to compare every character? Okay, do I need to compare? यहाँ से मुझे पता चल जाता है, यहाँ पे E है और यहाँ पे I है. When I reach here itself, I can make out that the strings are not the same, right? So I may not, suppose this is a lengthier word, okay? Suppose this is a lengthier word. So from here itself, I'm able to find out that the strings are not the same. So I might stop my process the moment I get to know that the strings are not same. So when do you use this REPE and REPNE? These two are mainly used for comparison, okay? When you want to compare and scan. REPE and REPNE are used for comparison. Keep this point in mind. So REPE will execute how many times? It will run maximum 10 times provided zero flag is a 1. And how many times will this run? This will run maximum 10 times provided what? Provided zero flag is 0. That means the strings are not equal. For example, okay, let me make this clear with an example. Suppose मुझे compare करना है index, ये मेरा source है जो data segment में है और मेरे extra segment में है India. Okay, I want to compare whether index and India are the same. So I'll be doing a comparison byte by byte only. Okay, तो first step में क्या करूँगी? I'll compare I with I, मतलब I of data segment with I of extra segment, right? तो यहाँ पे मुझे क्या कंक्लूजन आ रहा है? इक्वल है क्या दोनों? दोनों इक्वल है क्या? हाँ, इक्वल है. So if it's an yes, so I'll do repeat. I'll have to repeat the same procedure. Next, I'll be comparing what? I'll be comparing n of data segment with n of extra segment. Again, my answer is equal, right? Is it equal? Aren't they equal? Yes, they are equal. So what I'll have to do? I'll have to again repeat. Next, I'll compare D of data segment with D of extra segment. Again, it's a yes. So that means again, I'll have to repeat. Now, when I compare E and I, what will happen? Are they equal? Are they equal? Bolo Baba, are they equal? At least respond.
Ma'am, you are lagging.
Okay, fine. So when I make a comparison between E and I, are they equal? No, right? So do I need to repeat this? Do I need to repeat this further? Do I need to repeat the process further? Say yes or no. Am I lagging too much?
Yes, ma'am.
Yes, ma'am.
इसके लिए बराबर जवाब देते हो। हाँ? मैं जब क्वेश्चन पूछती हूँ तब आप लोग जवाब नहीं देते हो, तब कोई लैग नहीं रहता। See, what are we doing here? Here we are comparing byte by byte of data segment with extra segment. Here we are repeating. We need to repeat only if the characters are same. The moment our characters are not same, we need not repeat further, right? Here itself we can conclude that our strings are different. So what we have used here, which instruction we have used here, which prefix we have used here? We have used repeat if equal here. Only if the characters which you are comparing are equal, we are proceeding. Otherwise, we need not compare, right? We can stop. So here in this scenario, we can use REPE. Okay, sorry, I got disconnected. Let me just share the screen once again. Okay. So did you understand the scenario where we have used REPE? Did you understand? अभी तो जवाब दो.
No, ma'am.
You have not understood? Okay, I was lagging. Okay, fine. See, where is REPE used? What I want to do, what is my objective here? I want to find out whether index and India are the same. So first I'll compare I and I. Only if I and I are same, I need to compare N, right? Suppose मेरा इधर index है और यहाँ पे okay. Let me just change the connection, okay? Give me a minute. Okay. Am I audible now? Is there a delay?
Audible, ma'am.
Okay.
Yes, ma'am.
Okay. What I was saying is that REP is used when you want to compare as long as things are equal. Okay. So if you want to compare index and India, you will be comparing till D only, right? Once you get to know that E and I are not same, why would you want to proceed, right? Because here itself you can conclude that the strings are not equal. So in such a scenario, you can use the REP prefix. Okay. Now suppose you want to find out whether D is there in India or not. Okay. You want to find out whether D is present in India or not. So in such a scenario, what you will do? You will put D in the accumulator, right? You will put D in the accumulator. And then you will be comparing this content of accumulator with every character in your string, right? Now, so here, how long will you go and check? Until you get D, right? The moment you get D, you can stop your scanning process, right? Is that the logic that you will use? You just want to find.
Yes, ma'am.
So here, which prefix can you use? Which prefix can you use here?
REP.
REP? What? REP what? REP,
REP.
not E. When are you, see, first you will compare D and I. It is not equal, so you are proceeding, right? Then you will compare D and N, right? Right or wrong? First you will compare D and I. It's not equal, so you are proceeding. Am I making sense? I want to find out.
Yes, ma'am.
So first I'll compare D and I. Since it is not equal, I'll proceed. And then I'll compare D and N. Not equal. Again, I'll proceed. And I'll compare D and D. Now it's equal. I got a D. I got to know that D is present in India. So I'll stop here. So here in this scenario, which prefix am I using? I'm using
REP.
so these are different scenarios where you can use REP, REPE, REPNE. So whenever you want to do unconditional repeat, based on whenever you want to do unconditional repeat, you can use REP. Whenever you want a condition like you want to compare when things are equal or things are not equal, then you can go for REPE or REPNE. Got it, everybody?
Yes.
Okay. So which are the string instructions that we have discussed? Move as, load as, store as, compare as, scan as, and then along with these instructions, which are the prefixes that can be used? REP, REPE, REPNE. Right? And what are the rules that you have to keep in mind when you're using string instructions? Source should compulsorily be where? Data segment. Destination should be compulsorily where? In extra segment. So source is in data segment means which is the register? Offset register? SI. Extra segment, which is the offset register? DI. If you're using accumulator, as in load as instruction or store as instruction, if you're using accumulator, you have to keep in mind, if it is a byte version, you will be using AL as the accumulator. If it is the word version, you will be using AX as the accumulator. And for all our repeat prefixes, the count should be given in CX register only. So these are all the major points that you have to keep in mind when you use string instructions for doing assembly programming. Is that clear, everybody? Okay, so we have discussed all major categories of instructions till now, which includes data transfer instructions, arithmetic instructions, logical instructions, shift rotate instructions, machine control or processor control instructions, and string instructions. Now, using this knowledge, you can interpret and understand most of the assembly language program which is there in your lab manual. Okay. So as I said, I'll proceed for 15 minutes more because we have to complete this module today itself. Because there is a numerical question from your third module, which will take up 2-3 lectures. Okay. And that is there as part of your unit test. So I'm just proceeding for 10-15 minutes more. These are things which you already know. So it's going to be a kind of quick recap only. We have discussed assembly language programming in the labs. So we'll just have a quick recap of whatever we have discussed in the lab. What are the steps in writing an assembly language program? Come on, quick. What are the 4 steps I taught you are there in writing an assembly language program? Come on. First step,
Editor,
editing. Second step,
assembly,
third step,
linking,
and fourth step, executing.
executing.
Okay. Which is the file? .asm. Which is the file? Output file?
.obj.
What is the output file? .exe and
.exe.
and .map. And what do you get as output? The results, your intended results, right? Okay, so you remember this. Now, the next point that we have to revise is, what are all the features of assembly language programs? Whenever you write an assembly language program, what are the features? Okay, just a minute. Okay, whenever you write an assembly language program, you might have observed that there are many aspects in an many entities in an assembly language program. You might have seen that in your lab manual, when I've written programs, I've written something called as comments. Things which are preceded by semicolon are called as comments. Then you might have observed that there are certain words, there are certain reserved words which are used in writing programs. These reserved words include mnemonics and assembler directives. See, for example, you have a mnemonic like move, right? Move. You have mnemonic like add, sub. all these are reserved words. You cannot use these words as variable names, right? Suppose if you write add mov comma sub, can you do this? You cannot do this, right? Because these are reserved words. They cannot be used as identifiers, right? So reserved words come in two categories. One is those reserved words which are a part of the instruction mnemonics, and the other is in assembler directives. You know, we have used several assembler directives like dot model, small, then dot code, dot data. All these also cannot be used as identifiers in your program. What do you mean by identifiers? Identifiers means variable names. Okay. So reserved words, which may be instruction mnemonic or assembler directives, they cannot be used as identifiers. So the third element that you will find in your program whenever you write program is an identifier. What is an identifier? Say if I write num1 db5, num1 is an identifier. What does an identifier mean? Identifier means it is a user defined variable name, right? So are only variable names called as identifiers? No. Identifiers can come in two categories, okay? Identifier can be a variable name, or it can be something which is called as label also. Labels also come under the category of identifiers. By now you know what is meant by a label, right? If I write L1 colon add BL comma CL, what is L1? L1 is a label. Why do we use labels in a program? Labels are used to refer to the address of that instruction, right? Because somewhere in the program, if I write jump L1, what will happen? From this statement, my execution will jump to this particular statement, which is referenced by this label L1. So identifier means what? Identifier is a symbol, okay? It's a symbol or name that applies to an item in the program. So that identifier are basically of two types. It could be a variable name or it could be a label. So whenever you write assembly language programs, you may find comments in your program. You may find reserved words in your program. You may use identifiers in your program. You may use assembler directives in your program, right? So the fourth element which comes in when you write assembly language program is an assembler directive. What is an assembler directive? If somebody asks you, what do you mean by an assembler directive? What will you tell? What will you tell?
Statements that direct the assembler to do like something.
Yes, assembler directives are commands to the assembler, right? So that means it's an instruction to the assembler. So if I write something like this, move AL, 2H, is this an assembler directive? Is this an assembler directive? No, right? This is an instruction. This is an instruction to whom? This is an instruction to the MUP. But if I write dot model small, this is an assembler directive. This is not an instruction to the MUP. This is an instruction to whom? The assembler. So always keep in mind, instructions are instructions to the microprocessor. Instructions are commands to the MUP, whereas assembler directives are commands to the assembler to do something. Okay? And assembler directives are specific for a particular assembler. So depending upon whether you are using TASM, MASM, the assembler directives may differ. Okay, but almost all the popular assemblers like Intel's MASM, TASM and all have a similar assembler directives only. Okay, but what you have to keep in mind is that assembler directives are specific for a particular assembler. It can differ, but जो MASM TASM सबका है वो almost same ही है. So assembler directive is a command to the assembler, whereas an instruction is a command to the MUP. Okay, so we have used several assembler directives in our program like dot code, dot stack, dot data, dot model small. Apart from these, there are several other assembler directives also. Okay, we will use certain assembler directives as we execute programs. Okay, so you will get to know some more assembler directives when we discuss more programs in the lab sessions. I'll just list down some of them. Dot processor, dot processor, end, DB. We have used DB, DW, DD, defined byte define word, define double word, define far word, define quad word, define 10 bytes. All these are also assembler directives only. Byte means what? 1 byte you are reserving. Word means what? 2 byte you are reserving. Double means what? You are reserving 4 bytes. Far word means 6 bytes. Quad word means 8 bytes. 10 dt means you're reserving 10 bytes. So these are all assembler directives which are used for storage. Okay, so they are storage related assembler directives. There are certain words which are used as operators. For example, dup is an operator. It's an assembler directive only, but which is used as an operator. For example, if I write, okay, if I write num1 db 100 dup 0. This means what? This means that I'm reserving 100 locations for this variable num1. That means num1 is going to be an array. And all the locations in that array is going to be duplicated with the value 0. If I write n1 db 5 dup 2, this means what? n1 is an array, okay? And all the locations are going to be initialized with what value? With the value 2. So dup is an operator, an assembler directive which is used as an operator. There are several other assembler directives like this. EQ है, offset है, offset हमने use किया है. If I write move si, comma offset of some variable name, it means what? It means move the offset address of this particular variable in si. So offset is an assembler directive. If I write, say for example, factor EQ 12, it means I'm assigning the value 12 to this variable factor. So EQ means equate it. These are all different assembler directives which you will be using in the programs. Okay. So what all elements there can be there in programs? You may find comments, you may find reserve words, you may find identifiers, you may find assembler directives, you may find instructions also in the program, right? That means you may find statements also in the program. So the last category of entity which you may use when you're writing program is statements. So statements can be again assembler directive, like dot model small is a statement only, and it's an assembler directive at the same time. Then you can have statements which are instructions. For example, if I write L3, L30, and if I write move AX, comma 004H, okay, 004H. This is what? This is an instruction. So your program may have command statements. Your program may have identifiers. Your program may have assembler directives. Your program may have instructions. Your program may have what else? Reserve words. So these are all the elements which are used when you write an assembly language program. Okay. These are all things which you already know. I'm just revising that because it's a part of your theory also. Now you tell me. What are the various software interrupts that we have discussed so far? Which are the software interrupts that we have discussed so far? Which are the software interrupts that we have discussed so far? I'm just revising, okay? I'm not teaching anything new. What is move h, 01h used for? What is move h, 01h, int21h used for?
Reading single.
Reading a single character. Very good. What is move h, 0ah, int21h used for?
Reading a string.
Reading a string. Okay. What is move h, 09h used for?
Printing a string.
Printing a string.
Not reading, printing a string. What is move h, 02h used for?
Printing single character.
Printing a single character, displaying a single character. What is move h, 4ch used for?
Those exit.
Those exit routine. Okay. So what is so what all categories of interrupts you may use in your program? Apart from all these statements, assembler directives, reserve words, you may also use software interrupts in your program. Okay. Not only, so software interrupts are of two types. You may use DOS interrupts and you may also use BIOS interrupts in your program. Okay. So far we have not used any BIOS interrupt in our program. Whatever this INT21H is a DOS interrupt. So far we have used DOS interrupts only, but it is not a compulsion. You may use BIOS interrupts also while writing program. So what you have to keep in mind is 0 to 1FH is called as DOS, is called as a BIOS interrupt. Okay. And 20 to 3FH is called as DOS interrupt. मतलब अपना 21 कहाँ पे आता है? अपना 21 ये कैटेगरी में आता है ना? See if I write INT21, this 21 comes in this category. So जो interrupt का जो number है, if it falls between 20 to 3F, it is a DOS interrupt. Okay? ये जो INT के बाद जो आप नंबर लिख रहे हो, interrupt number जो है, वो अगर 0 to 1F के बीच में है, then you are actually making use of a BIOS interrupt. Okay? We also have a program in our experiment list where we are using many BIOS interrupts to manipulate cursor. Cursor जो अपना cursor screen पे display होता है ना, उसका size बढ़ाने, उसका size छोटा करने. That means for video related operations, we will be using BIOS interrupt. So apart from all the entities which you have discussed, your program may also, in your program, you may also use software interrupts. Okay. And software interrupts come in two categories. Interrupts are identified by INT followed by a number. So depending upon where this number falls, your interrupt may be a BIOS interrupt or a DOS interrupt. So if the interrupt number is between 0 to 1F, it is a BIOS interrupt. If the interrupt number is anything between 20 to 3F, it is a DOS interrupt. Okay. Then coming over to the last concept, which is macros and procedures. Okay. We've already discussed macros in the practical session. So let me just directly go into procedures. Okay. So remember I told you a difference between macros and procedures. Does anybody remember the difference between macro and procedure? Does anybody remember the difference between macros and procedures? So apart from reserve words, comment statements, software interrupts, you may also use this concept which is called as macros and procedures in most of the assembly programs. Okay, that is why we are discussing procedures and macros now. Now what is a macro? Bolo, what is a macro? At least wo to batao. Macro kya hai? How do we write a macro? How do we write a macro? Macro name followed by the keyword macro, followed by parameter, followed by the body of the macro, and followed by the keyword endem. Right? This is how we write macro. What is macro used for? For repeating a set of statements. Right? If I want to print something, I can write a macro for printing. Right? क्या लिखूंगी मैं? LEA DX, LEA DX, whatever I want to print, its offset address is to be loaded into DX. And then I can write move AH, 09H, INT21H, endem. So this is my macro for printing. Wherever I want to print something, I'll be just calling this macro print. M1, agar mujhe message M1 print karna hai, I'll be simply calling M1. So macros and procedures are used for repeating a set of statements. And I also told you what is the difference between macro and procedure. See, I know it's going above your head. You are saturated, but we have to complete this portion today itself. Okay, because tomorrow we have to start with the third module. I'm sorry for extending this, but we have no other option. Just try to listen. Procedures and macros are used for repeating a set of instructions, a group of instructions. Okay, you already have some idea about macros because we have used the print macro in the second experiment. Now what you have to know is about procedure. Okay, a major difference between procedure and macro is that procedures are written only once in the memory. Okay, whenever you call a procedure, okay, suppose if I want to write a procedure, I have a syntax for writing a procedure also similar to this. So how I'll be writing a procedure is, I'll have a procedure name followed by the keyword proc, followed by either far or near. Okay, the keywords far or near. And then I'll write the body of my procedure. And then I'll have this instruction, which is called as RET. And then I'll be writing my procedure name end P. Okay, this is how I write procedure. Now, what is the meaning of this? This is the procedure name. If I want to write a procedure for printing, I'll be writing print, proc. I'll write either far or near. Now, what is this far or near? See, if my procedure is in the same segment, is in the same code segment, okay, I'll be writing what? I'll be writing near here. If my procedure is written in the same code segment as my program, I'll be writing near here. Suppose my procedure is written in an entirely different code segment, then I'll be using the keyword far here. Okay. Then whatever I want to put, see, the same statements will come inside the body of my procedure. And then RET, print, end P. So what does the statement mean? This means end procedure. Which procedure? End procedure, print. So this is the syntax of writing a procedure. Procedure name followed by the keyword proc, followed by whether your procedure is a far procedure or near procedure. A procedure is said to be a far procedure if your procedure is written in a different code segment than your original program. From where are you calling this procedure? You are calling this procedure from your main program. Okay. Suppose your main program is written in one code segment and the code for your procedure is written in a different code segment, then your procedure is not a near procedure. It's a far procedure. If both your procedure and the program from which you are calling that procedure is in the same segment, then your procedure is called as a near procedure. Okay. मतलब अगर जब भी आपको एक प्रोसीजर लिखते हो आपको उसको कॉल करना पड़ता है. That means the syntax for calling a procedure is call followed by procedure name. Okay. So if I want to call the procedure print, I'll be writing call print. मतलब the procedure print will get called here. And this procedure is written in memory only once. But अपना macro वैसा नहीं है. Macro के केस में मैंने कुछ बताया था. याद है आपको? What does macro do? Every time a macro is invoked, suppose I'm writing a statement print M1 in my program, what will this print M1 be replaced by? This single statement will be replaced by all the statements in the body of the macro. That means machine code is getting generated for that macro multiple times. Wherever you are invoking that macro, machine code is getting generated for that macro. But procedure का वैसा नहीं है. Procedure आपने एक ही बार लिखा है and you are simply calling that procedure. So if you are calling that procedure, that means call, अगर आप किसी को call कर रहे हो तो return भी करना पड़ेगा. मतलब if I am currently executing a program, okay, suppose this is the current program which I am executing. यहाँ से मैंने एक प्रोसीजर को कॉल किया. समझो मैंने फैक्टोरियल के लिए एक प्रोसीजर लिखा है and I call that procedure called fact. So क्या होगा? I'll go to that procedure, I'll execute that procedure, and then I have to come back and complete the rest of my program. So whenever you call a procedure, you're actually going somewhere else, and then you have to come back. So that means whenever procedures are used, you have to push the return address onto the stack. Without using stack, you cannot implement the concept of procedure. So whenever your procedure is being called, the return address has to be pushed onto the stack so that after executing that procedure, you can come back and execute your resume with your original program. Okay. Did you understand the difference between macro and procedure? Macro में कोई return address नहीं है. Macro में क्या हो रहा है? जहां पे भी आप macro को call कर रहे हो, that statement is getting replaced by all the statements in the body of the macro. That means if you are calling this macro 10 times, these many statements, the machine code for these many statements will get generated every time. But procedure का ऐसा नहीं है. Procedure आप memory में एक ही बार डाल रहे हो और उसका machine code एक ही बार generate होगा. Did you understand?
Yes, ma'am.
Yes. सो जब भी आपको कोई सेटअप स्टेटमेंट्स रिपीट करना है प्रोग्राम में, जब भी आप ऐसा कोई प्रोग्राम कर रहे हो जैसे फैक्टोरियल या फिबोनाची सीरीज, जहाँ पे आपको रिकर्शन का कॉन्सेप्ट लगता है, so you can make use of the concept of procedure or macro. Okay, macros are used only when you want to repeat very few lines. But अगर आपका मैक्रो का बॉडी ही बहुत बड़ा है, मैक्रो में ही 10-20 लाइन है, तो मतलब it's actually an overhead. So in such scenarios you will not use macros, you will go for procedures only. But procedure का प्रॉब्लम क्या है, प्रोसीजर को आपको कॉल करना पड़ता है, और प्रोसीजर whenever you are using you have to use call and return instruction. और ये कॉल एंड जो रिटर्न जो इंस्ट्रक्शन है, इनका ओवरहेड बहुत बड़ा है. ये कॉल इंस्ट्रक्शन जो है वो एक 3 बाइट इंस्ट्रक्शन है. So call and return instructions create a lot of overhead in the program, because every time you want to call a procedure, you have to use the call instruction and you have to use the RET instruction also to return. So that is why that is a drawback of procedures, of using procedures. Okay, so if the number of statements which are there which are to be repeated, okay, if the body of your macro is too small, then the better option would be to go for a macro. But if the code that you want to repeat, आपका function का ही code बहुत बड़ा है, तो it is advisable to go for procedures. Procedures are of two types: re-entrant procedures and recursive procedures. Okay, बहुत simple है, don't worry, I'll wind up in 5 minutes. Re-entrant procedure मतलब, समझो मैं एक प्रोग्राम कर रही हूँ मल्टीप्लिकेशन का प्रोग्राम. ओके, ये मेरा प्रोग्राम है मल्टीप्लिकेशन का. सॉरी, मैं एक प्रोग्राम कर रही हूँ, एक नॉर्मल प्रोग्राम कर रही हूँ. वहां से मुझे बीच में एक प्रोसीजर को कॉल करना पड़ा. मल्टीप्लाई का प्रोसीजर मैंने लिखा है, आई हैड टू कॉल दैट प्रोसीजर. मतलब व्हेन आई रीच हियर आई विल गो एंड एक्सिक्यूट द प्रोसीजर फॉर मल्टीप्लिकेशन, राइट? समझो, when I was executing the multiplication procedure, when I reached halfway through the multiplication procedure, I got another interrupt. That means now I'll have to stop this multiplication procedure here and I have to go and execute the ISR, right? That means after executing the interrupt service routine, I'm going to come back, I'm going to complete this multiplication procedure, and then I'll go back and I'll complete my original program. This is called as a re-entrant procedure. Okay, re-entrant procedure मतलब क्या? A program is called re-entrant if it can be interrupted in the middle. So when it is interrupted in the middle, what will happen? The control flow is transferred to some other procedure, right? So your control will go to that procedure, you will complete that procedure, and then you will come back and you will resume the program, right? So a program is called as re-entrant if it can be interrupted in the middle, and if the control can be transferred to outside that program. Okay, that might be because of an interrupt or some jump instruction or some call instruction. So if you are able to transfer the control to some other point in the program and then come back safely and resume your previous program which you were executing, then it is called as a re-entrant procedure. Okay, for example, if you look at this diagram here, you are executing a program, वहां से आपने multiply का procedure call किया, you went and you were going and executing this multiplication procedure, बीच में आपको एक interrupt आया, तो आप वो interrupt को execute करने चले गए. interrupt के service routine में फिर से you are making a call to multiply. तो मतलब interrupt आधा रास्ता, जब आप interrupt का procedure जब halfway पहुंच जाता है, there is a call to multiply instruction in the program. So that means again you are going to the same procedure again. तो क्या होगा, फिर से आप multiplication complete करोगे, फिर वापस आके interrupt का procedure complete करोगे, फिर से वापस multiplication में आओगे, ये procedure complete करने के बाद फिर से आप आपके main program में जाके you will resume the execution of your main program. Such a procedure is called as re-entrant procedure. You are re-entering. So such procedures are called as re-entrant procedure. समझ में आया? It's similar to your example which I gave you. You are watching a video, you got a phone call. When you are attending the phone call, you heard the doorbell ring. So you want to service that doorbell. वो doorbell में जब you were entertaining that person, another person came. So what? You will entertain that another person first. फिर जो ओरिजिनली आया उसको एंटरटेन करोगे, फिर वापस आके आपका कॉल रिज्यूम करोगे, फिर वापस आके आप अपना मूवी रिज्यूम करोगे. दिस इज अ री-एंट्रेंट प्रोसीजर. डिड यू अंडरस्टैंड?
Yes, ma'am.
Yes. The next category is called as a recursive procedure. अब ये recursive procedure तो आपको पता है. You know what is meant by recursion, right? See, I'm executing a program. I made a call to, suppose I've written a program to find the factorial of a number. Factorial can be implemented using recursion. You know that, right? तो अगर मुझे 5 factorial find out करना है, I can write it as 5 into 4 factorial. This 4 factorial will be what? 4 into 3 factorial, right? This will be what? 3 into 2 factorial. This is what? 2 into 1 factorial. So factorial can be implemented using a recursion. So what am I doing here? I am executing a program. I'm making a call to a recursive procedure. Within that procedure, again, I'm making a call to the same procedure. Such a procedure is called as a recursive procedure. That means a recursive procedure is a procedure which calls itself. For example, factorial is an example of a recursive procedure, right? Because to find the factorial of 10 or 20, you are using the same factorial, you're calling the same factorial procedure recursively. Such procedures are called as recursive procedures, okay? So these are two different types of procedures. So what we were discussing is macros and procedures. So apart from assembler directives, reserve words, identifiers, comment statements, software interrupts, you may use macros and procedures in your program wherever you want to implement some logical construct which needs to be repeated every time. So either you can go for a macro or a procedure, and you need to understand the difference between macro and procedure. Macro requires more memory, right? Because every time you are invoking that macro, the body of the macro replaces that single statement. So it requires more memory. Procedures are written only once inside the memory, so it requires less memory. Macros do not require call and return instructions, right? But procedures require call and RET instructions. Machine code is generated every time a macro is called. As far as a procedure is concerned, machine code is generated only once. Parameters are passed as part of the statement. How do you pass a parameter to a macro? As part of the statement. If I write print M1, M1 is a parameter which I'm passing to the macro print. How are parameters passed to procedure? Parameters are passed to procedures using registers or using memory addresses. That means you will be passing the parameter within the body of the procedure itself. For example, if I'm writing a procedure to add, okay, I'm writing a procedure to add. Suppose so here, how will I pass my parameter? If I write add ax comma bx, okay, and then ret, and then add end p. This is my procedure. This is my procedure for adding the content of two registers. How did I pass my parameter to the procedure? I pass the parameter to the procedure in the form of registers, as content of registers. So whenever you are using procedures, you can pass the parameters in registers, or you can pass the parameters in memory locations, or you can pass it using the concept of pointers, or you can pass it using stack. So whenever you are using procedures, parameters can be passed in registers, memory locations, or stack. Okay, but macro में कैसे pass करते हैं? Macro में parameters are passed as part of the statement itself. Macros execute faster than procedures. Procedures are completely slower. Why? Because procedure के case में call और return का वो overhead है, and procedures are comparatively slower because of that reason. Okay, so you do not have the overhead of call and RET in macros, but in procedures you have that overhead of using call and return instruction, because of which procedures are slower in comparison to macros. But आप memory consumption के case में compare करोगे तो macros consume more memory than procedures. Okay, so did everybody understand the difference between macros and procedures?
Yes, ma'am.
Okay, so that's it. So we have completed the second module. The second module is all about instruction set and assembly programming. Assembly programming, we are learning it in the lab. Instruction set we have discussed in detail during the lecture sessions. Okay, and now what we have done is we had a quick recap of whatever we are actually using in the lab for writing assembly language programs. Okay, we'll wind up for the day. Those who have not marked your attendance, please mark your attendance. Consists of a set of rules or productions, like we said in our And if you have marked your attendance, you can leave. Okay, each of which will express some way or the other that the symbol of the language can